So we're down to our last presenter of the day. Paul Little from Air Hygiene is here. By the way, Air Hygiene sponsored our break back here, so you can thank Air Hygiene for all the food that's back here this afternoon. Of note to the other vendors who are in the room, I didn't ask anybody to do that. Shane might have, but I didn't ask anybody to sponsor anything. But some of them came forward to us and said they wanted to do that and wanted to participate and help out in some way or something like that with the costs or whatever, and appreciated the time to be here. But Air Hygiene stepped up, and tomorrow morning's break is Rockwell Automation. But she was so excited about coming. She was begging us to have a break where she could sponsor something and do some other things there. So, but they'll talk tomorrow morning on their stuff. All right. So Paul's our Air Hygiene from Broken Arrow, right? Did I get their name? Tulsa, Oklahoma, which is where Wes moved to, by the way. He's right down the street from these guys. But they're going to talk about stack testing. And I put him last on purpose because I thought that would be a lot of stimulated talk about what they do, what you need to know ahead of time and all that other stuff. So I kind of envisioned this as being the most interactive group of the day. That's serious. I meant that.
I'll have to admit, this is my first presentation in what seems like 4 years. So it's good to be here. Appreciate the opportunity. And yeah, so what I'd like to talk to today is keys to a successful RATA. So I know all of you guys, gals at your plants need successful RATAs. I'm Paul Little. I'm our Director of Customer Service with Air Hygiene. But performed my first RATA in 2002, and I was there to perform the RATA because almost a month before we were there performing the RATA, and we were told that they would send us the data, after we were off site. And we're nearing a month, and we still haven't received any data, and we never received any data. Weren't able to get the data. And so I was sent back out there to repeat the RATAs, my first RATA, and R&B Consulting had been invited out there to witness us do the test, and it was pretty stressful. But it was a Tenaska's here. It was a Tenaska plant in Georgia. It was not a CiSCO CEMS. It was first time RATA on the CEMS, and there was just some issues with some data recording that hadn't been realized at the time. And if the data had been pulled while we were on site, we wouldn't have run 4 RATAs and demobilized just to come back and run 4 RATAs again. So this is, let's get to, all right. So what I've got here, if you guys would, apparently this is a better spot to stand. I'll stay more in the tape. So if you'd like to try to scan this with your phone, this will be sent out. This is I want to leave you with a written standard. So if nothing else out of my presentation, this is a checklist that we have put together, and it's a RATA review checklist. So you can pull this up, and for a lot of folks here that are pros and been through this, you may not need it. But at least you'll have this. If you have someone new working for you that hasn't been through a RATA before, there are 37 items here that we feel like are beneficial. So this will be kind of our approach to RATAs, which is probably very similar to other service providers in our industry. And then we can discuss, some options you can look at that'll be advantageous. Oh, wrong direction. Okay, so we kind of break down our projects into 5 tasks. We have pre-mobile, things that should be done before we mobilize, things that are done on setup, things that are done on test day, and then our kind of post-test debriefing before we're off site, and then report. Before we mobilize, first thing really important, of course, is test protocol. We've got to get that test protocol put together and to you guys for review. And then after everyone agrees this is what we need to do, it's right, then we can get that submitted. And in that test protocol, we're going to list the parameters we want to test, the methods we want to test them by, and then, you know, an example schedule so folks understand how long, you know, we're looking at for this test. And then also before we mobilize, the week before we mobilize, we send our project managers some data from, if we haven't gotten your monitoring plan, a copy of that. Tom will log into ECMPS and we'll get information, load information about the units. And one of the biggest issues we run into with RADAs is, are we at the right load? And you know, we've got to get those loads defined, and how do we do that? So we'll get that data from ECMPS, and we'll plug it in to get, you know, what is our normal load, what is our secondary normal load, because we have repeated more RADAs because the RADA was run at the wrong load than we have probably for all other reasons combined. Not very often, I would say occasionally. Yes, sir. Mm-hmm.
Whatever that turns out to be, make sure it matches what's in the monitor. Yes.
Right.
It's gonna look at gas riding, did it mid load, it's gonna go. I do a range analysis.
Right.
Load analysis, excuse me. Go to the monitoring plan. It's not your normal or second normal.
Yep. We prefer to get it from the monitoring plan, but if we can't beforehand, this is what we can get it from ECMPS, and there's also another website we can get it from. And occasionally, they, depending on how often things are, when they're updated, sometimes they don't even match there. So we try to get it from the site when we can, but if we can't, this is what we start with. Yep.
Load analysis. Where I operated.
Yep. Yep.
During my time.
Sure.
Make sure that matches.
Yep. We
prior to the RADA, two ways of doing it. Prior to the RADA, I say I'm doing it in the third quarter. Second, first, fourth, and third last time. Or you can take the date of the RADA, and I think it says you go back like, I forget what, 4 quarters, 365 days from that date. Two ways of doing it, right? But no, you shouldn't be updating your normal every quarter, every month. I would do it once a year.
Yep. Right.
Yeah, I mean, there's flexibility though. If you're gonna do you're gonna do the RADA next quarter, do your load range analysis this quarter and the 3 quarters. Sorry.
No, great information. Yes, sir.
So, contradiction with the old part 75.
Yeah.
I understand that. That's another reason why.
Yeah.
if high was one of your two normals, but what if it's high, what if low and mid, you're up the creek?
Oh, no, I'm just saying, but like, if you know, it's going to give you a better chance. Reconcile.
If high is your normal or second normal based on your workload now, you're okay. If mid and low, you gotta do maximum.
Up.
Yeah. I know.
Yeah. I was gonna say, well, all I would know is to do 2 ratas if you told me that, but yeah. Yeah. Yeah, a lot of people here better, from a stack tester's perspective, all I would know is I'm going to have to do one. If it falls out, I'm going to have to do one to satisfy your permit. And then I'm going to have to do one where we can upload data and, upload the data and not have it kicked back. So. Yeah.
Say something off the record. I don't know if there's a correlation between your anywhere's in the load range. Yes.
Right.
So why and then do I have to do it at 1 more second? Let me do it like a mercury rider.
Yeah.
You allow mercury riders to do the whole operating.
Right.
Because we went to OQPS and they said there is no everything. That makes sense, actually.
Sure. Yep.
So if I ever got a chance to change part 75, now not flow, stack flow, there's a direct correlation between stack flow and load. Gas riders, let you do it just like you were peaking. Very on the operating range, but I can't say that now.
We thread the needle because it's supposed to be above 50% for the.
See, that would alleviate the problem. For the load range.
Yeah.
Yeah, but then we stuck with part 60.
But note that part 2 is
Right.
part C.
And these are per people. They're written to all
By the way, what I said was my opinion. I don't know.
Sure. You heard it here first. Yeah. Well, great discussion, and I think so. You guys can probably understand why the majority of I'll say I was a project manager for 5 years, and I had to repeat a couple of ratas. Each time it was because of load issues. I didn't understand this real well, and as a stack tester, some people will take the approach that I'm not operating the unit. I'm just here to collect emissions data and monitor emissions data. But we all know what we do. I can remember the last unit that had to be repeated for a rata that I was doing was the customer came to me and said, "Hey, I'm just going to drop the duct burners out. The turbine's still going to be at full load. What do you think?" Sounds good to me. Yeah, and it was the last 2 runs of the rata, and always run 10 runs on a rata, and I ended up with 8 runs where we needed to be and 2 runs where we didn't, and we were near the end of the quarter, and we had to remobilize very quickly, but we did get it done. So that load study, like I said, we got to get that done early and know. We send that to our managers the week before, so we get them thinking about it. Had some advice here that says there's better ways to do that, and that is true. But that's part of our process to get us going and kind of understand where the unit needs to be and start that conversation with our contact. Setup day, time synchronization. We have 7 offices and we test units throughout all the time zones. So we always have to match our data logger with the site data logger, and then we want to check. In all of our protocols, we have the unit numbers, serial numbers, those things. They're in there. We check them all the time because occasionally things get changed. Folks don't know. It's a good time during the RATA to just get a sanity check. On that, on setup day, we need to discuss how long this is going to take, because obviously operations needs to know. Um, we hope we can get there, and if this is a power plant, which seems like most of these questions have been, and it's nice and hot, and the unit's going to run at the same load for 10 hours, then we're good. If it's not, if we only have 6 hours of run time, I need to know that ahead of time, because I normally don't count a stratification test as the first run of my RATA. I can, but I have enough other stuff going on. I like to use that. But if I know we only have 6 hours of time available, I might need to, go ahead and start counting that first, that stratification test as part of the RATA. And then on setup day, it's great if the unit can be running, because we can start talking about how are we looking. Are we going to pass on what we see today? If we're not, time to start me to start looking at my stuff, and you guys to start looking at your stuff, and see what's the problem. And so that's where I go here. If everything matches up, it's good. But what if it doesn't? That's when we have to start. That's when the hard work starts. We like to work systematically. It doesn't do us any good if we're jumping here, jumping there, jumping back. So we kind of start at the top and work our way down. I'm going to have my, I don't climb the stack too much anymore. So, I'm going to ask my colleague up there, can you look through that port and peer, is the CEMS probe still there? Because that's happened before. These things have sheared off, and you just don't know until something doesn't match up, and that's happened. As long as we're talking about probes, could it be my probe? I've had this happen before on CiSCO RATAs, where I've showed up at a simple cycle turbine, and all of a sudden I'm reading high, and normally the higher number is right. 9 times out of 10, but this just isn't making sense. So we had to come up with a color coding schedule where we paint all of our probes. So we have low NOx probes, mid NOx probes, and high NOx probes, and we paint them. And if you have a low NOx probe, that thing needs to be used at 5 ppm or less, because I have off-gassed over 2 ppm of NOx out of my probe before, because I had it somewhere, and I don't know what got in it or what got on it, but something got in those pores, and now I have it in a 850-degree stack temperature, and I'm off-gassing. So that can be important. Sample lines. Are all of our lines heating? Are we heating, to what temperatures, with temperatures we need to be at? Leak checks, need to leak check, and these are all pretty easy things to do. Now we get into, yep. Yep. So that's going to come in my kind of my reference method QA, but that is true. Ranges, that's one of the things I'm recommending. Ranges need to be checked. We'll just skip over that when we get to it. But my goal is to, at the very least, match the CEMS range. So if you're running 100 ppm, my highest range is going to be 100 ppm, but I'm probably going to pack some ranges lower than that as well. This doesn't happen so much in power, but it happens in manufacturing and cement and other things sometimes, where they may have a 100 ppm range, but because of the materials they're running on that day, we're running down at maybe 10 ppm. So in that case, if I have the gases, I'll usually calibrate down. I might calibrate to a 20 range, at that point. Method 7E says that, for NOx, methods tell you your range can only be a certain percentage higher than the gas that you're monitoring. You can't be more than 30%, below your range. But on RADAs, typically it's pretty safe if you can match the CIMS range, that everybody's cool with that. But yeah, your tester really shouldn't be there with a range above your CIMS range. It just doesn't, it doesn't make a lot of sense. So, we got to look at calibrations. If we're not matching up, you look at your calibrations. I'm going to go back, look at my calibrations, and see where we are. What parameter is it? Is it NOx? If it's NOx, well, we need to look at, is it, how does our NO compare? How does our NO2 compare? A lot of times on a natural gas fired combustion turbine, we don't have a lot of NO2. So, both of our NO2 is going to be reading, pretty close to nothing to begin with. But we're getting units now with hot SCRs where they're pumping a lot of air in, and our NO2 percentages are going up. I have to run an NO2. I run an NO2 conversion every morning. As soon as my NOx analyzer is calibrated, I run my NO2 conversion, make sure I'm at 90%. But that's not something that's done on the CIMS often. So maybe it is with you guys, but it's not in a lot of places. So we can run an NO2 converter check on the. I use around a 45, something around a 50. There's some alt requirements that allow us to do NO2 conversions that way, and it's normally around a 50 ppm gas in air is what we use, and we have that with us, so we can provide that gas to you guys if we think there is an issue with the NO2 conversion. It is not common. We do, well over 100 RADAs a year, but we'll see one or two every year where, that's the issue, and we can go there. We can do calibrations with shared gases. Now I'm pulling stuff off of your unit. You're pulling stuff off of my unit. We got to be real careful when we're plumbing this stuff back up that we get the bottles turned back on. I don't like to do that, but now we're getting into more evasive things, but we may have to do that. And if that works, then we may have to tap into each other's sample systems. Really don't like doing that. Got to be careful. Really got to know what you're doing. You need to understand your customer's system and have them out there with you so they can understand that, are you tying into a vent? Is there enough flow out of the vent? You can do that, or are you going to have to go and tie into their gas conditioner? Same thing with your system. If you're running your system over to their conditioner, those are things that can be done, but got to be real careful doing it. If it's not NOx, if it's SO2, and they're not matching up, it's probably a heating issue in one of the sampling systems. And if you're running higher than me and I'm running lower than you, I'm going to troubleshoot that a long time before I tell you I got a problem, because chances are it's me and I'm scrubbing something, out of my system. So it's analyte dependent, kind of where you look as well. But that's those are kind of the tools we have in our tool bag. And then we can talk a little bit about calibrations. If we get to calibrations, go ahead. %? Yeah. Yeah, not 90. That's a standard for me by method 7E. So I have to be at greater than 90% conversion. I don't know if there's a standard, for you. I don't believe there is. Yeah, that's just my standard that I go from. But if we run the NO2 conversion and we're down at like 20 or 30%, yeah, we get a common sense approach to that. We do have ammonia standards. We don't use converters for our ammonia. We use method 320. So we use an FTIR. So we have to do dynamic spikes with ammonia. So we will have an ammonia cylinder with us when we do the ammonia RADA. Mm-hmm. Okay.
You actually started.
Yep.
What stability are you guys?
Yep.
And so you end up with access 47 and 3.
We use a lot of NO2. I have 22 test labs and I have an NO2 bottle in every single one of those. I use it every day. And or like I said, around somewhere between a 45 and a 50 ppm blended in air, we're not having any stability issues. Yeah, and I shouldn't say that because we probably use ours quick. So I don't know. Yeah, I don't know that I can answer that for you very well because we burn through our bottles, I would guess, every 6 months. I would guess a bottle probably doesn't last us more than 6 months. Yeah, but we do have bottles that sit in consignment, so we're set up with our gas supplier that, they'll have, 3 bottles of NO2 sitting in consignment for us at all times. So sometimes I really don't know how long those bottles sit there, but I'm not aware that we're having any issues with NO2 stability. So another thing that I need to hit on setup day is, and Reggie hit on this, are the constants. So if my ppm values are matching up well, and then we get into the RADA, and all of a sudden, my ppm for NOx is 5 ppm, and or is 5% relative accuracy, but our pound per hour is at 15% relative accuracy, and we're doing method 19. What in the world's going on here? Well, we probably have different heating values for the gas in there. So I need to get F factor and GCV from you guys and get that plugged into my system if we're doing method 19 for mass emission rates, so that so that we're on the same page with our ppm comparisons as well as our mass emission rates. So test day. CEMS calibration. If we get there in the morning and we're iffy, and we look, and for some reason, if the let's just say the CEMS came in high on its bottle, everything's in, but it came in high. Well, let's recal this back into the bottle. It's going to bring us closer. So we go into service mode, do a calibration. Got to do an online calibration after that's brought back in. That can be forgotten a lot of times, that we've got to do that. We've got to go back if any adjustments are made to that analyzer and do an online calibration before we start that RADA. And we need to coordinate when is the CEMS calibration going to happen. Because if it doesn't happen really early in the morning, chances are it's going to happen right in the middle of one of my runs. Okay.
You gas call it gas for the gas. Never see the 1 minute. Gas route report. A colleague of mine came to me and said on page 156 of this test report, why is there black font and red font? What is it? Test run. 14 minutes into the test run, they get a word. True story.
Yep.
Now, they had a couple other runs extra that they started and they used those. You talk about a pain. Go back and redo the entire report, plus just the embarrassment of EPA doing an audit, and you're trying to, because ECFS doesn't see that.
Yep.
Again, I told you guys, it doesn't see the 1 minute data.
Yep.
It sees an average.
Yep.
It sees a start time and a stop time. As long as those start and stop times 21 minutes apart, it assumes that value you gave me is good. That's how dangerous it is. It's a great tool.
Yep.
But it assumes you guys know what you're going to. So please coordinate with Air Hygiene or whomever your stack minister. Don't let up. Well, that was the other one. He was looking at some of the flow runs, and sure enough, they were letting flow calibrations go off during some of the flow runs. Now they were, or flow runs only have to be 5 minutes. Again, Probably would always have to go without saying, but
Well, and that's when it's really important to share data in real time. So a lot of times we'll show up on site to do errata, and folks are busy. The person we're dealing with, there's not a lot of extra staff on this site. We might be, one extra thing added to their list. We start, and how's it looking? It's looking good, and then we don't see anybody again until the errata is over. I didn't get any data, I didn't get any, run by run reports. And now, we're kind of in a panic, going into the end of the day, because this isn't what you want to be reporting at the end of the day. But it's important to get those runs as we go, because if I do, I can see that, oh shoot, I've got a 21-minute report here and I have flags on this data over here. What was going on? Damn, the AutoCal kicked off right in the middle of run 3. So that's okay. I'm just going to go ahead and run an extra run. And we're not going to use run 3. That's going to be one of the runs I discard, and I'm going to use run 10 or 11 or 12. So it's very important, and we all have technology now. It doesn't have to be a person on site. It could be someone off site. If I can email them, the run times, and then they email me back. The majority of power plants now, we have signal boosters and things. It is very rare. I mean, of course, it happens. But it is rare when we're at a site where we can't, send email and we can't text. So we can even, if you give us a contact off-site somewhere, even at corporate, that can get into the system and print the, email us the router reports. I like it run by run, or at least every 3 runs. So we got our calibrations done. We've talked about how long, again, we want to check on dispatch for the day to make sure that we have the time at the loads that we need to be. So now I need to run a stratification test. And that stratification test is normally going to take me somewhere short of an hour, depending on my response time and how quick my guy is with port changes and those kind of things. That stratification test, if I can get data from you, during that time, that's a great opportunity for us to determine how things are looking. Are we good? Are we going to be close, or are we out? Go ahead.
you can also use that
We sure can. Yep.
at the minimum 20.
Right. Right. Absolutely. That strat test can be run 1. And then also I have a whole other presentation on picking points, test points to get into. But then once we get that stratification test done, now we got to start, picking test points. And the test points have to match my method requirements, but they also need to, I need to try to find the best spot, for the CEMS as well. But I can't always just go in there and park the probe in the port closest to your probe, because my stratification results might not allow me to do that. And now my 21-minute runs might even be longer, because I may have to sample from 12 points if stratification's bad enough. So now I have port changes in the middle of here and things like that. So our day's getting a little longer. Oh, I'm sorry.
As long as you can get 21 per. You should have a run time 12 to 12:30 with 5 minutes of purge in the middle of that. Or there's 5 minutes, you can rest a minute. Could be a run. I would just suggest not having a run like that. It's odd. I wouldn't use that. I would just start it. It's like, well, ECMP's not going to know the difference.
It's not that, it's not. What is it? Trying to get it through the system. Yeah, account for everything. So, yes, the question is that if that had to do a 21-minute long data, that had to do with maybe 20. and that we just challenge, because that's actually representative, you have a back purge, and that affects the operation of.
Part 75 says you have to have 21 minutes paired data. Paired data, the key there, meaning that sampling stack efficient. Paired data, 21 minutes of paired data, minimum for a sample run. That's the part 75 requirement.
That's still data, it's just.
They're not going purge, they're sampling stack it. Can't compare stack it to purge.
Well, the thing is that, I guess this is an offline conversation. Thing is that the back purge is an integral part of the form every hour. Sometimes it's all fast food every 15 minutes. You have a biomass plant, you do that every 15 minutes. How are you gonna get your work? Say that purge on that thing. All of that is that the emissions that we report are for the back purge. Question is, this is talking about, I guess that's what the risk of validating a rata. You're collecting that data. If paired data is the data, and that's back purge.
You shouldn't be using per minute data to average in for your hourly.
Right, sometimes, but it should be good.
Yeah, right. Software's picking that out. Not considering that valid
The
data.
software.
CiSCO is better for you.
Well, I understand that. The simple resolution is to have one rata. I understand. This is being more of a conversation off. And there's also a precedent, those with the reports that require that, say just run it free. Stop the rata. Like I said, so I get your.
Yeah.
No, it's good.
No, this is good. Yeah, it is good. Very good question, because, I start thinking about time shared CEMS, when this is going on, because you're switching from one, to the other, and they're locking a value in, for that time. And I'm wondering, how do we, how is that done? Yeah.
In between the run, in between. You have a process for.
Yep. So, we all good on that one? All right. Walt said this was going to spark conversation. He was correct. Yeah, you called it. I'm thinking nobody's going to be really. It's late in the day. Nobody's really going to be that interested in what I'm talking about here. So. Yeah. Sir, good advice. So one of the things I'd mentioned, we're kind of getting our test day started. We kind of have a post-test review. Before we get started, we might want to talk about those things we want to talk about in the post-test review. Before we get going, we'll hit that in a minute, but just so we have the information, we can discuss at the end of the day. So we're in and we're testing, and we're started now. We're going. So we can talk about questions. These are just questions to ask during the day. So we're getting our load going. We're going to monitor our load, make sure we want to be as stable. We want to keep load as stable as we can be with power plants. fairly easy. Sometimes manufacturing processes, especially batch processes and things, it's not always possible. But we try to keep load as stable as we can in the correct load ranges. Are we combusting primary? Are we on primary fuel? We sampling at correct points? Is our NO2 converter efficiency where it needs to be? Did the RATA pass? And then this is interesting. Is there a bias adjustment factor? This is probably something that we should talk about beforehand. I have customers that have a no bias adjustment factor policy. That they would rather pay me an extra day to stay there while we keep comparing these CEMS and keep running stratification tests and keep doing things to where at some point and if anybody, I think most of you, but a bias adjustment factor is when we're running a Part 75 RATA and my results are higher than yours. So now we're going to get done. There's going to be a bias adjustment factor that you're going to have to put in there. So if bias adjustment factors are an issue for you personally, or it's your corporate policy, that's something I do need to know ahead of time. And I have enough customers, and it's not as bad as it used to be. I used to do a lot of RATAs up in the Northeast. And when there was a lot of, when NOx credits were worth a lot of money, there were a lot of people that were back in an office somewhere that were real curious about that. Ida? Right? 1.11. Well, you could do, what I've seen a lot of people do is a non-routine calibration. So Part 75 has what's called a non-routine calibration, where folks will tag a value that is higher than the calibration gas, but still within passing criteria. I see some shaking heads here about, go right ahead. Yeah.
Now, bias adjustment factor thing. The reason why people don't like bias adjustment factor, they read Part 75 and says, if you fail a bias test,
Yeah.
oh my gosh, I failed a test. I can't do that.
Yeah.
There's a connotation with that, and it's wrong. You're not
Yeah.
failing anything. It just means that your CM on a statistical basis is
Mhm.
a little bit lower than the reference.
Right.
So we're going to bring you up to the reference. So when people say, well, I don't want to fail a bias test, well, what does that mean? It means I'm above the reference number. If you like over reporting EPA, have a. I don't understand why. It could get you into trouble with that, yeah, but see, we don't do bias adjustment factor on a PPM basis.
Right.
I doubt it would affect that.
Because either you have a bias adjustment factor, or you're right. So then you do it because you calibrate there, or you
We have some customers that feel if they have a bias adjustment factor, that's great, because they're actually measuring and reporting, low, and now they have a calculation that's going to, bring them up to the highest point. They don't want to be above us. They want to be below us. So there's two different, there are two different camps on that. Okay. Yeah. 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 Yep. Yeah.
You know, just being analyzer, high concentration, doesn't really work out. That's kind of
Yep. Right. Yep. Yeah. Yeah. I was just asking, so I said that's some of the things that I have seen. Yeah, I don't get into providing a lot of advice in those situations. I just want to make sure that we've had an online calibration after all this is done and it passed the online calibration, and I'm good to, good to start my ride. But these are all things that happen, while we're there, and we have to make sure we have discussed those, and it is a real thing. I mean, there are locations, with corporate policies about bias adjustment factors. And if any of you guys ever end up working for any of those companies, you have to let us know before we get started so we can communicate, where we are with you. Yep. Nope. No. So, we can get into, if we're part 75, we need QSTIs these days. That's something that, you guys, questions you should ask. And then, was the company, an AETB? That's important. Definitely need to have that checked out. Did all the systems pass for calibrations? Did your reference method runs follow the proper QA? Like Reggie said, is it ranged correctly? You don't want someone there calibrating on a 500 range when your CEMS is at 100 range and the unit's running at 30 ppm. We're breaking, a lot of reference method rules if we do that. Do the RADA runtimes match? So a lot of confusion is between, I like to send a start time and an end time, because if I want to run a 21-minute run and it starts at 8 o'clock, that's 8 to 8:20. But for people that haven't done this a lot, they think that's 8 to 8:21. So now I have my 21-minute run with your 22-minute run, and we have to compare like and con, time ranges, and that can cause issues later. Probably not going to cause any issues with compliance, but it could, we could be back here, recalculating this all the, time. One of the other things I wanted to mention on load, I forgot on this, and I've had issues with this before on flow riders. So a lot of times when we run our multi-load flow riders, I'm doing mid-load and low load at night. We're gonna get all the high load stuff knocked out during the day. We're gonna go back to the hotel for 6 hours, and then we're gonna come back and knock out the mid load and the high load at night. When we're doing a 3-load RADA, a lot of times the night crew doesn't change loads as much as like the day crew does. So they said, okay, 100 megawatts is our separator. So to be in the mid load range, I want you to operate at 102 megawatts, and to be at the low load range, I want you to operate at 98 megawatts. Well, we got to have a 25% difference between those ranges. So load just gets, even more complicated. On flow, we have to remember that we have to have that 25% load difference. We can't just come in there and do a set of flow runs here, change the unit by just a couple megawatts to drop just on the bottom side of that limit. It seems like it makes sense, but we've had to redo flow riders before because that happened, and we didn't, whoever our manager was in the field wasn't aware of it. We need 9 runs for the RADA, and then was each run 21 minutes? Okay, maybe it was. It doesn't have to be. It has to be at least 21 minutes. A lot of times, I'm doing RADAs in conjunction with a Part 60 compliance test. And that Part 60 compliance test needs to be a 60-minute run. So I need a 60-minute run for NOx for permit compliance, but I only need a 21-minute run, for NOx for RATA. Well, it can be a 60-minute run for permit compliance and a 60-minute run for RATA for those first 3 runs. Well, we don't want to run this unit all day, and it's a part. It's a part 75 RATA. Along with that, we have part 60 and part 75. So a lot of times we might run a 63-minute compliance run, and if it's part 60, you've got a bias at the beginning and end, and you break that thing into 3 21-minute runs. That's okay if it's part 60. It's part 75, you can't do it because you have to have a drift and bias check before and after every run. Part 60, you don't. If you fail the bias check, you lose 3 runs. You lose the whole thing, but you can't do that for part 75. And there's confusion, around that. But for the most part, I'm not a big fan in doing a 63-minute run and breaking it into 3. But I will if you tell me you can't operate. If it's part 60 and we got to shut the unit down, we can have that happen. But when you do that, be aware that you can get caught up on part 75, needing that drift and bias after check after each run. You can't do it that way. Okay, so I just showed you all these questions, and I've got a 37 question checklist that I can share for you if you weren't able. I think are these presentations going to be sent out? Yeah, you can scan that little code and pull it up and have it. Maybe you don't want to do all of this. Let ECMPS do it. It's pointed out that ECMPS isn't perfect. There's some things you can, but it's a damn good tool to use for comparison. So what we do is we have a policy every time one of our field managers finishes a RATA, they have to email it to our QA team. And there'll be someone ready if it's finished at 8 o'clock at night to run it through the ECMPS to make sure we don't throw any errors, based off of what we just did. It's a good check. We like to do it. It has saved us many times. But you guys have seen these tables. It's late. We'll get in there. So XML code. One of the things we do is we've developed our software. We can push a button and it'll export out all the XML code that we can provide to you guys so that you can upload your data. It's not terribly hard to do. If you're a stack tester and you do MAC testing to begin with, you have to report into the ERT, all your part 63, results anyway. So if you guys don't like entering XML data yourself, just put it in your RFQ and tell them, I want you to send me, XML data, along with the RATA report, when you're done. Stack testers have the capability of doing that. And like I said, honestly, it can help make us all better because we can run the data through in real time, while we're there before we leave to catch errors. Because we've had these outcomes before when we've got back to the office and haven't done that. We just did 4 RATAs and we did them all at the wrong test load. Or we had RATAs reported using the wrong load, like Ida said. CiSCO's nice because they have part 75 megawatts. Guess you guys still have that. You had that, when I did it, and my part 75 megawatts were my turbine megawatts along with my steam turbine, megawatts. So it helps you. It can identify if you thought you were at high load, the CT was at high load, but didn't realize steam turbine was only at half load and you weren't where you needed to be. And believe it or not, we've had RATAs before where somehow or another something came in and it wasn't 9 runs. Well, you're going to find out right then, and you can knock out another a couple of runs in the morning. Advantages, and this is, real-time feedback is critical because we're there and it captures our field manager in the moment. Because why is that important? 2 days later, they're on another job, focused on something else. And we don't find any of this again until, we're 2 weeks into it and sending in draft reports. And then if something did go wrong, it's always easier to apply corrective actions before we demobilize and are off site. You always can't guarantee that the unit's going to operate the next day. Hopefully it will, but if it doesn't, if it's 2 or 3 days away, it sure is a whole lot easier to do that then than to try to schedule and another remobilization. So just like the ECP MPS, for us, kind of the future is now, is what Tom likes to say. We built our own. We kind of see the ECMPS as a robot, that kind of takes all of these things. We have our own robots where we go through our report checks to make sure that we can load our reports in there and push a button. And I don't know, I think her name's Pam or whatever this program is, but she runs through all of our reports to make sure that our analyzer numbers match. All of our test dates match. Our template versions are the latest versions, that we ran, because, as part of being an AETB, you can't just take the template that you did, the year before and use that for this year's RITA. If that's not you got to use your newest versions of your templates. If that's not the newest version of your templates, that doesn't work. So we have a robot now that will capture all of that for us, and all the robot is Excel program. Services and options to help. We kind of brought up on the XML reporting. You guys really should lean on us to do that. We're capable of doing it, and I guess we're going now from XML to the JSON code. I know there's a little bit. We're part of a beta group that with the new cloud-based ECMPS version 2.0. So right now, I know Tom's taking our old data, doing it the old way, and taking our new stuff, or taking the same data, running it through the new. And if we see any discrepancies, we're sending that to EPA. And I'm assuming other stack testers are doing that. So if they are, they're already generating the XML data, anyway, to do this. I can't imagine, we're the only ones that are part of this beta test. We are crazy. Yeah. Well, yeah. So our president tasked Tom Graham and I to put together. He wanted to sell some things on the internet. Sell some things on the internet. What in the world are we going to do? So the first thing we did is scan on this. You can go. We have about a half dozen little things on sale on the internet for $10 an item. But this is pretty handy. It's a RITA tool calculator, and Tom says here, automatically generate XML files compatible for upload. So may help you out, if you want to go and buy a copy of that. We do have some other cool things on there. If you ever get like a gas composition, C1 through C6 plus, and you want to know what your high heating value is, and you want to know what your your F factor is, and you don't want to go through all the calculations, you can pick that up there too, and save you a lot of time. And then we have a button to convert from at 60 degrees to at 68 degrees, because you have the power standards. A lot of times what you get from Texas Oil Tech or SPL or whatever is at 60 degrees, because that's where all your performance guys and all your turbines are, guaranteed 2 on heat rate. Well, with the EPA, we're usually looking at things at 68 degrees. So if you don't have it in the right units and you don't want to wait on them to do it, I don't know, it's $10 or whatever on here. You can get that and download it yourself. And I don't know anything about these codes. I learned C++ when I was in school, but I think that's like 1980s or 90s. So right now there are issues with supply chain. And if you have an analyzer part that breaks and you can't get it for 2 months and you need an analyzer, call us. We have a lot of analyzers. I think we have 4 out right now in different fleets that are being rented. If we'd like to help you. If we have something sitting on the shelf and you have a down piece of equipment and you know what the problem is, but you can't get the part to fix it for several days, let us know. We have a full temporary CEMS at a cement plant right now that we've done RADA on and certified as FTIR, because the FTIR they have, we've been there for 3 months now, and it still hasn't, they haven't gotten the part that they need for repair. Cylinder rental, we have a large fleet of gases. If you ever end up in a gas bind, reach out to your stack testers. Chances are, we probably have, I think we have 430 cylinders in our warehouse right now. So if you need something, there's a good chance I can help you out with it. And then Air Hygiene University, there's not a lot of training in our industry. So we have an indoor stack, and right under it, we have a CIM shelter, with a rack of analyzers in there. If you guys ever hire anybody new and want to get them some training, or you want to get some training on something yourself, contact Tom Graham with us. He's our director of training. We train our people, we train regulators, we train our competitors, we train our customers. We're passionate about continuous improvement, and that's how we're going to improve our industry, is training. So if you guys hire someone into a position and they don't have much experience, Tom can help out with that. Tulsa, Oklahoma. So we're about 13 miles from the Tulsa airport, and Nevada DEP sends 8 people in every 2 years for training their folks. We have people in every week. It's become so routine. I probably should be up there more involved. I don't even know who's in, most of the, it's totally customizable. You tell us what you need to know, and Tom will work with you on, what you're interested in, on what you need. Right. If you want to know more, so most of the regulators, what he does is, we have a smart board right here, and then we're up on a mezzanine, and then we have a 10-foot diameter stack right here. So we can go through the CFR, we can go through method 5 on the CFR, and then we can set up an impenger train, a probe, a meter box, and then we can talk through what you just saw on that paper to help you understand what it means from an observer's, perspective. Oh yeah. Yep, for sure. We got a lot of FTIR stuff because we're training the heck out of our people right now too, with this new Quad Y regulation. And there have been so many different, PADEP. We've had a lot of webinars through the SES over the past year and that kind of thing. So FTI, method 320 QA is in certain locations almost changing on a project by project basis. We send in a test protocol and this is what you want, and then we get done with the test and now we need all these things too. So it's evolving quite a bit. You know, the state of Michigan's wanting to completely, you know, rewrite the whole thing. PADEP's always had their own methods. Reggie. Right. Yeah, it's free. We don't charge for it. Yeah, we did for about a year. I think it was like a $250 option, but this has been years ago. We've been doing this with XML for quite a long time. So you should. Yeah. Uh, well, and it's our fault because we should be offering it to you. Yeah. I mean, we should be asking you when we send you the report, you know, do you need the XML files? That's, yeah. I don't understand that. Um, it shouldn't be a task. If it is, you probably should start nosing around, you know, to see why it is, because we should be 9 out of 10 riders that I run, I'm plugging in data run by run, you know, at the beginning of every run, because I'm wanting to see where we're going. You know, I want to see if we're coming together, if we're drifting apart. I'm counting on when I start that rida, my relative accuracy is going to get better every single run throughout the day because our confidence coefficient is going to get smaller. And, you know, that's in the numerator. But if you start going up here and I start going down there and we start flip flopping each other, and now my confidence coefficient's getting out of control, and my RA's getting bigger, you know, we gotta know that. And at the very least, after the third run, um, you should be poking your head in to see, you know, where are we at? Because that's the point where we got to decide: are we moving forward with this thing or not? And right, right, yep. And that makes good points. So a lot of times we get finished with this thing, and you know, I have a manager on site that wants the bias adjustment factor right now, because they're going to run straight in there and plug that into, you know, plug that into the CIMS, you know, immediately. And now we're in report review, and it's decided that we're going to throw out run 5 instead of run 7, and we throw that out, and now it's different. Um, but yeah, it's one of the dangers of having everything ready, you know, right then. But it should be ready. At the end of the day, we should be able to email out a summary report, you know, with, you know, 10 runs, 11 runs, 12 runs, 9 runs, whatever it is, and the, you know, the runs that we use, and then the actual RA for, you know, each of the parameters. Now, you know, there's certain things like ammonia. You know, you get out and you're doing ammonia, and you're going to do ammonia by wet chemistry. I still feel like you should be doing on-site analysis and plugging that in as you go. But you can be, you know, several, you know, couple runs behind after you get that third run done, and, you know, everything's looking good. You're going to go throughout the day. You know, those titrations or the IC runs or those things, you can get a little behind on that. But there's not a good reason why, as a stack tester, we can't give the customer a summary at the end of the day. I mean, we should. That should be expected. You guys should demand it.
But there's also another thing that has to do with our, yeah, we're right here, the DOC, yeah, a whole bunch of local rules. That's one guy in the left. So that's really put down. Really has to do with that's all that.
So Paul, thank you very much. I told you. I told him that exactly what happened was going to happen before it happened. And it always, I'm not usually wrong on this because I read the audience pretty well, but I knew ahead of time where this was going to fall just based on conversations we have on a regular basis. So we ran late today. Hopefully tomorrow we'll be more on time, but I think today was worth a lot of great talks. Bob was here, Scott was here, Paul was here. Who else talked today? Doug was here. So we had a lot of good talks, a lot of good people from the vendor side, and thanks all my people. And then we'll see you tomorrow morning about 8 o'clock. Thank you.